Hello, and welcome to notes number 6. Today we're going to take a look at some more examples using the elimination method. So again, we're solving a system of equations where we've got two different equations together, and we're focusing on the elimination method. Today's examples are going to be a little bit more complex than the examples that we've seen thus far. So the method, however, is exactly the same. So here it says step 1, we're going to write each equation in the same form. Now I see the example that we have here is 16x minus 10y equals 10. The second equation is negative 6y equals 6 plus 8x. So in this case, it's not lined up. Here I have x and y together on the left side of the equal sign. Here I have y by itself, but the 6 and the 8x are on the other side. So what I'm going to do is that I'm going to rearrange one of these equations so that they line up. Well, in the first equation, the x and the y are together on the left side. So what I'm going to do is in the second equation, I'm going to subtract 8x here so that instead of being on this side, it'll be on the left side with the y, so it'll line up with this one. Okay, so what I'm going to do here is on the second equation, I'm going to subtract 8x from both sides. 8x minus 8x is 0. So on the left side, I want my x first, just like it is in the first equation. I'm going to write negative 8x minus 6y equals, on this side, the x is canceled, and I just have 6. So the reason for doing this is now that I've rearranged the second equation, it's in exactly the same form as the first one. The x term, the y term, your equal sign, and then the 10. Okay, so I've lined it up exactly. So now I can see when I put the second equation right underneath it that they're lined up in the same manner. 16x minus 10y equals 10. X's here, y's, your equal sign is lined up, and the constants. So that's step 1, is to rearrange your equations so they're lined up. Step 2, multiply one or both equations by a number to get the coefficients that are opposites. Well, when I look right now, nothing is opposite. My x coefficients are negative 8 and 16. Those are certainly not opposite. My y equations are negative 6 and negative 10. They're not opposite either. So I'm going to multiply one of these equations by something. Now I notice that 16 is a multiple of 8. 8 times 2 is 16. So if I take this top equation and multiply everything here by 2, then they're going to be the same. So what I'm going to do is I'm going to say negative 8x minus 6y equals 6. This equation, I'm going to multiply everything in the equation by 2. Because in doing that, when I distribute, I'm going to get negative 16x minus 12y equals, and I have to do the same thing to the other side also, 12. So the purpose in doing that is now when I line up the other equation, let me line up the other equation underneath so I can see it clearly. The other equation says positive 16x minus 10y equals 10. I haven't done anything to that other equation. But now they're lined up, x's, y's, equal sign, constants, and the x coefficients are opposites, negative 16 and positive 16. So this is exactly what I want it to be. Because now in step number 3, I have to add these equations together, just like we did in the other examples. I'm going to add these equations together because when I add them together, the x variable will be eliminated. 0, negative 12 minus 10 is negative 22y equals 22. So this is a very easy equation to solve. The x's are eliminated, so step 4, when I solve this, I just have negative 22y equals 22. I'm going to divide both sides by negative 22, and I get y equals negative 1. Okay, so even though the initial equation seemed a little complicated, it's pretty easy to get y value. First, I rearranged the equation so the x's and the y's and the equal signs and the numbers lined up. Then I multiplied one of these equations by 2 so that the coefficients are opposites. Now that I know that y is equal to negative 1, step 5 is to plug it into either equation. It doesn't matter which equation I pick. Either one will give me a good value of x. So I'm simply going to use the second equation. So I have negative 6 times negative 1 is equal to 6 plus 8x. Negative 6 times negative 1 is 6, equals 6 plus 8x. I'm going to subtract 6 from both sides. So 0, 6 minus 6 is 0, which is fine. 6 minus 6 is 0 here, equals 8x. I'm going to divide by 8, and x is going to equal 0. 0 divided by 8 is 0. So now I have my answer. X is equal to 0, y is equal to negative 1. Or again, you can write it as a coordinate, 0, comma, negative 1. Then the check is just like any of the other checks we've done. You go back to the original equations, not the ones that I rearranged, not the one that I multiplied by 2. I go back to the original question. I like to copy down my equation, and I think that x is equal to 0. So I'm going to do 16 times 0 minus 10 times y is negative 1. And I'm going to see, does this equal 10? Well, 16 times 0 is 0, minus, this is negative 10. Here I've got a double negative, which makes it positive 10 is equal to 10. Yes, 0, negative 1 works in the first equation. Now I'm going to take a look at the other equation. The original form, which was negative 6y equals 6 plus 8x in the original form. Negative 6 times negative 1. Does this equal 6 plus 8 times 0? Well, negative 6 times negative 1 is 6. This is 6 plus 8 times 0 is 0. So 6 equals 6? Yes. So I can be confident that we have the correct answer. X equals 0, y equals negative 1. Okay, so in these examples, we had to rearrange the equation first to line them up. So the first step is to rearrange the equation so all the variables are lined up. We want to line up the variables. Then, once the variables are lined up, we're going to multiply one or both equations maybe to get the variable coefficients to be opposites. Okay, so let's take a look at another example. In this example, we've got 2x plus y equals 10. And then we've got y equals 2x minus 6. Well, this is not lined up. In the second equation, I have y by itself, which, by the way, is a nice way to do the substitution method. But here we're practicing the elimination method. I want the x's and the y's together here. So in this second equation, I'm going to subtract 2x from both sides, because I don't want it on the right side. On the right side, I'm just going to have negative 6 equals, and on the left side, I'm going to put the x first, because that's how it is in the other equation. So I'm going to put negative 2x plus y. Well, now let me take a look at my two equations here. Let me rewrite the first one underneath it so I can see it next to each other. 2x plus y equals 10. So I lined up my variables in step 1. Step 2 says to multiply one or both equations to get the coefficients to be opposites. Well, these coefficients are the same, 1 and 1. These, negative 2 and positive 2, these are opposites. So I don't actually have to multiply by anything. Here, I'm ready to just add the equations together, because when I add these equations together, the x's are going to cancel, and I'm going to get y plus y is 2y equals negative 6 plus 4 plus 10 is equal to 4. So now, to finish solving, all I have to do is divide by 2. Y equals 2. Now that I know that y is equal to 2, I can substitute 2 in either equation to find the value of x. So I can use the first equation if I want, 2x plus y, I know y is equal to 2, equals 10. I'm going to subtract 2 from both sides. 2x equals 8. Divide by 2. X equals 4. So there's my solution, or as a coordinate, 4, 2. The x coordinate first, then the y. Okay? So in these examples, follow the directions. The first thing you have to do is line up the variables. In example 2, the variables are not lined up, so you have to rearrange one of the equations to line up the variables. Then you might have to multiply by something to get the coefficients to cancel each other, to eliminate one of them, and then you finish solving. So please do examples 2, 3, and 4 on your own. When you do number 4, please try the check. It's good practice to see if you did it right. And as always, bring any questions that you may have to class. Thank you.